books, laptop, gadgets. So everything what happen, you will be taking help of this and you upgrade yourself. Okay, let's begin with the I pre-written so that we can discuss many numericals. Okay, now we have a function. The maximum minima, I'll come to the bit. First, we'll learn some how to differentiating. Already we know. Let's a bit further higher level. I'm going. Okay, this is a function where y equal to 3x cubed minus 2x squared plus 4. Let's try to plot a curve of it. The curve will be of this nature. Are you looking at this? The curve will be like this. This is what for plot y equal to 3x squared minus 2x squared plus 4. I'm showing clearly. So this curve is specifically related to this particular thing. The equation is related to this particular curve. Okay, now we'll differentiate this. We know we are very good in the derivatives little bit to some extent. Okay, dy is equal to 3. So this 3 will come here, x to the power of 3 minus 1 dx, 2 x to the power of 2 minus 1 plus derivative of 4. Now, what is the derivative of 4? Will be 0 because 4 is a constant. Then this 3 into 3, 9, 3 minus 1, 9x squared dx minus 4x dx plus 0. Okay, this will be 9x squared minus 4x dy by dx. This every time writing dy by dx will be different. Y dash will be right. So this will become first order derivative. The symbol, this called like a y dash first order derivative. Can I differentiate again? Yes, we can differentiate again. Then this will be y dash is equal to nothing but dy by dx. So what is y dash? Slope of tangent down in y-axis graph. Already we have a definition. Means I'll calculate the slope of this curve. Somewhere it is 0, no here. Again 0 here. And what's happening? Slope, positive slope. It was maximum, decreases, become 0. You draw a tangent, slope of the tangent will be 0, you know. Then again it becomes negative, increases. Again it decreases, becomes 0. Again positive slope starts increasing. So the slope is varying here. That variation we are trying to learn, you know. That variation we are trying to learn. So now dy by dx equal to how much? This is it. So let me differentiate again. So dy dash is equal to, this will be 9 into 2 x power of 2 minus 1 dx minus 4 into 1 into x power of 1 minus 1 dx. So dy dash by dx is how much? 18x minus 4. So this, if you find difficult, you can write it as second order derivative, you know. So d square y by dx square will write it. So what is the basic idea? If you have if you differentiate again, this is written as d square y by dx square. Later in the mathematics, you are going to explore all these things. Derivative of this is a d by dx. It should be written. So this what happened? We just show it in a very simple way. Y double dash. Okay, this is what I did here. dy dash by dx. Or you can also write it as, these are the various symbols. Or this is equal to y double dash. Which all you prefer, you can go for it. I'll do prefer this. Very simple to scribble. Dy dash by dx. I'll differentiate again. Okay, the dy double dash. So I go this one. So there's nothing but d square y by dx square 18x minus or y double dash. Can I differentiate again? Yes, again I'll differentiate. The derivative of dy double dash is equal to, this will be 18 x to the power of 1 minus 1, derivative of 4. Again, derivative of 4 will be 0. Finally, what do we get? dy double dash equal to 18. Or this, we will write it as y triple dash. This will become third order derivative. So therefore, what we can see now, this will become first order derivative. Second order derivative. Third order derivative. Sir, nth order derivative, what you can write? Nth order derivative dn y by dxn. This will become nth order derivative. We can differentiate n times. Okay, now I think there won't be any problem for you to differentiate a function. We can differentiate for n times. So double differentiation, let's not bother. First, we should have a confidence. Can we differentiate that for n times here? No. Okay, let's go for this one. This is the dy by dx. Y dash is there. So what is the curve? 9x square minus 4x. The curve will be of this kind. This is dy by dx, I'm plotting it. Then what about y dash? Y dash is just 18, no? So the dy, this is what we have plotted. This is dy by dx. This is y dy by dx. Y double dash is 18x minus 4. It's like an equation of straight line, slope 18, intercept 4. We have here. We can plot, we can keep on plotted. You should have a patience. There's the equation of straight line. There's a curve. There's a curve. Okay, fine. This is, so what is actually meaning? What is this red curve? The variation of slope of this at various points on this black curve is what? That variation of slope is what I put here as a function of x here. Again, if I calculate slope, it will vary of this kind. I think it's quite clear. Slope is negative, becomes 0 here. Again it increases. Again, it increases. Everywhere, the idea of slope is very important. Huh? You have to stick on to that. Okay, we can differentiate n times. Okay, now we'll go to the okay, let's take some function y equal to minus x squared plus 3x plus 2. Let me plot that. How to plot it? We don't know anything maxima minima. First we'll go for it. Put x equals 0, 1, 2, 3, 4, and minus 1, minus 2 of that order. Then, so and I think if you are very good in quadratic equation, you can also check the points where it will intercept the x-axis. For that, put y equals 0, solve this equation. You'll get the curve where it will intersect the x-axis. That was the idea of quadratic equation. If you want to work out here, I'm more interested in explaining some other idea. I know you see that x equals 0, 1, 2, 3, 4. For corresponding values of y is what I'm getting. Then I'll locate all. Put x equals 0, y will be 2. X equal to 1, y will be 4. X equal to, again it is 4. Somewhere the 4 is here only. 4 is not something somewhere. The 4 will come somewhere here. Then x equal to 1, 2. X equal to 3. Again it starts declining. X equal to 3, it will be 2. X equal to 3, it will be 2. Then x equal to 4, minus 2. It will become negative. Or x equal to minus 1, it will be negative. Minus 1, minus 2. Okay, somehow we got a curve. I'm more interested in this. Sir, how you why you are putting this maxima where it is? Can you predict? So where that maxima I think will lie between this one. Is it 4 maxima in this column? 4 is the maximum value. Is this maximum? No. We do have certain value. You do one thing. Then what we should do? 1.1, 1.2, 1.3, 1.4. We have to check here. Put x equal to 1.1, 1.2, 1. We have to break up this from 1 to 2. We have to break up. How much of smaller intervals you break up, then it's easy to search. But what to break up? So shall we break up like this? Shall we break up here? I think I have. I'll move this. I'll bring it late on so that you'll not get confused. No, look at this one. So let's start breaking up. Sir, what do you mean by breaking up? Between 1 and 2, can I start like this? This is 1. For 1, what is the value? 4. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. Okay, again we got first. So now in between where it is maximum, again big headache, no? Then you may end up like a 5 and 7, maybe 5 and 7 same value. Then 1.57, 1.57. Again, what you're going to do from 1.5, 1.50, 1.51, 1.52. I think there is no end like this. 1.59, 1.6. Or say 1.5 and 1.7. Oh, I think it's a big headache. So this will become 69 and 1.70. Then you may say that maybe so like again, like it is the value 1.58 and it is lying between 1.62. So again, you are going to break up 1.58, 1.581. I think it's a big, we are landing in very big trouble now. So what was my question? Where exactly, what is the maximum value of y? Is it 4? The answer is no. There is a certain values which is more than 4, the curve. And at what value of x, y will be maximum? What is my primary question? What is the maximum value of y? And at what value of x, y will be maximum? I think these are the questions. Let's ask ourselves. What is maximum value of y? And at what value of x is y maximum? There's a $1 million question it is. Maximum value of y. How to find out? I think there's no way. We have to struggle a lot. So is there any mathematics which will help us? Because I can't do this like an analysis here of this kind. First, what happened? We will start searching between 1 and 2. Okay, 1 and 2 we started searching. Then maybe what will happen? We may feel that something it lies between 1.5 and 1.7 maximum. Then again from 1.57. So again 1.58 to 1.62. Again you have to break up. So here 1.62, no. So this will be 1.61. 620,619. See the headache what we are going to face. Again, if it may be between certain values like this. No, it's very, very difficult. This is something not advisable. Like this, fighting with the making a guess of values certain. So there should be some scientific method to predict the maxima. That is what we are trying to do. Okay, let's first analyze this particular curve. What is the slope of the curve at point A? This theta, you're going to draw a tangent. That particular curve the tangent will make an angle theta, and how you measure theta? Counterclockwise. So slope here is positive. So then the slope of the curve keeps on decreases. Positive value, it decreases, and it becomes 0 here, where at maxima. Then again the slope start decreasing. So you can say better magnitude increases, negative value. So what's happening to the function altogether first? The value of function increases, becomes maximum, decreases the value function, the value of y. Slope, it is decreasing, becomes 0, then it starts increasing. So there is some sort of like to search maxima. I think these are the ideas enough. These are ideas enough. So therefore now what I do is like, and similarly, let's go for minima. Let's learn minima, that one. Similarly, this, can we call this as minima? I want you to only see this part. See this one here. Look at this function, the value of y. So some equation I can write it. So it is the value itself what decreasing takes the lowest value, then it starts increasing. Then let me choose 2 points. What is the slope? Slope negative. Slope positive. The positive slope starts decreasing here. So you can say positive slope. Here it is more, no? The positive slope, sorry, negative slope, sorry, very sorry. The negative slope, the magnitude of negative slope start decreasing, become 0. Then it starts increasing. So therefore, definitely to search the minimum, this is the minimum value of y. So the minimum value of y is somewhere here. We have this what? What is our primary question? How to find out this minimum value? How to calculate this minimum value? That's what we are trying to search here. How to find out this minimum value is what we are trying. At one specific value of x, the minimum is occurring. So again, shall we use same method? Trial and error, trial and error. No. So what is the basic observation? The slope of the curve at minimum also it's 0. Then there's a difference is there. What is that? The slope starts increasing, become 0, then further increases, or better say the negative value decreases, become 0, then it will change sign from negative will become positive, and at minima it will become 0. So these are the things which I am going to take help of. So I'll directly put a condition for maxima. I want you to make observation of both. For maxima, what we can write. I'll take this so that you can. Let's make first maxima. For maxima, what is the condition we can put it? For maxima, hope everyone is able to see. Fine, now. For maximum, what is the condition? The slope should be 0. In y-axis curve, slope should be 0. You draw a tangent, the tangent will be parallel to x-axis. So the slope is 0. Then what about the second order derivative? Will be less than 0. Then it is said to be, the function is said to be, any reason for that, you can say the slope itself is the positive value, the positive slope decreases, becomes 0, then it becomes negative. So therefore the derivative, the second order derivative will become negative. How to find out second order derivative? Just now I demonstrated. Similarly for minima, what is the requirement? For minima, what we can write it as? For minima, what is the necessity condition? The slope again will be 0 because there's a tangent. Then the second order derivative should be greater than 0. Or y double dash should be greater than 0. That particular point is called as a critical point. So slope at a, already I think we have discussed this. Okay, what is the basic necessary condition for maxima, minima? These are the conditions what we use. Let me summarize there. For maxima, first order derivative will be 0 at a point, and the second order derivative should be less than 0. For minima, the first order derivative will be 0, and the second order derivative should be greater than 0. Minima greater than 0, maxima, second order derivative less than 0. Please do remember. This is the idea what we have propagated. Okay, let's propose. We'll take a problem. Okay, this was our question. I want to find out the maximum value of y, and where do it will occur. This one I don't know this one all. So I started with this equation: y equal to minus x square. See this. Minus x square plus 3x plus 2. Okay, this is the equation what we have. Then let me take the first order derivative of it. Dy is equal to minus of 2 plus x to power of 2 minus 1 dx, 3 into x to power of 1 minus 1 dx, derivative of 2. Okay, the derivative, as it is a constant, its derivative will be 0. Then we'll simplify this. This derivative of this will be minus 2x plus 3. See this here, the first order derivative. Let me differentiate again. This is called like a y dash, no? Dy by dx is called as y dash. Look at the symbols. Let me differentiate again this function. Dy dash equal to minus 2 into power is 1, 1, x to the power of 1 minus 1, power rule of derivatives into dx plus derivative of 3. Derivative of 3 again constant, so we'll get 0. So dy dash by dx. So this what it is called as y double dash, which is minus 2. So what is the value of this? Or d square by dx square. So this is less than 0. If they're less than 0, what do we expect? Maxima should exist for this. Okay, there a magma exists. How to find out that value? Equate this for 0. At maxima, what is the condition? Dy, the slope will be 0. So dy by dx equals 0. Or y dash must be equal to 0. Anything? So let me equate to 0, then I'll get x equal to 3 by 2. So where at x equal to 1.5, it will be maximum. How to calculate that maximum value? This value of x you have to substitute here. So when you solve it, what do you get? Y is equal to minus of 3 by 2 whole square, 3 into 3 by 2 plus 2. So this will be minus 9 by 4, 9 by 2 plus 2. Solve it, we'll get maximum value 17 by 4. Now I reached boundary. Yeah? Okay, this is 17 by 4. That's what I wrote, maximum value of y, 17 by 4. The maximum what we get it here. Okay, I agree this. So these are the ways in which we can find out. So I think this is the best, easiest method. No? Somehow you should learn that how to find out the second order derivative and the first order derivative equal to 0 and solve it. Well, exactly, I'm getting that one. If you don't use this method, what you should do again, put x equals 0, 1, 2, 3, 4, 5, 6. Again, you have to start searching where for what value of x, y will be maximum. Very difficult, it'll take a lot of time. Let's move to the next question. I brought one equation like y equal to x square minus 2x plus 3. Let's first take the first order derivative of it. dy equal to 2x to power of, applying power rule, 2 minus 1 dx minus of 2. Here power of x is 1, 1, x to power of 1 minus 1 dx. Derivative of 3, let it be. It will be 0 in the next step. Derivative of constant is 0. Then dy by this dx, I'll send it to LH in the denominator. Dy by dx equal 2x minus 2. There's a y dash, dy dash, we'll write also y dash. Let me differentiate again. Then this will become dy dash by dx will be 2 or y double dash will be 2. D square by dx square is equal to. Is it greater than 0? Yes, it is. So therefore, minima exists for this function. Just mere looking at first order derivative, we cannot differentiate between, we cannot find the difference between the maximum and minima. The second order derivative will help us to identify whether maxima or minima exists for a function. So minima exists for a function. What I should do? This first order derivative I should equate to 0 or y prime or y dash, anything, any of the symbols. Y dash must be equal to 0. So what is the value at which x will be, y will be minimum, x equal to 1. Substitute that value here. 1 square minus 2 plus this all will get the minimum. So minimum value of y is how much? 2. So the curve will be like this. There's a rough idea, no? So now it will be very easy, no, for us to plot where it will be minimum at x equal to 1. And what is the minimum value of y? It is equal to 2. This is what? Then we have brought one more curve. What is this? This is the slope. Slope of what? Slope of this curve. How the slope of this curve will vary? In this way. Y dash is what? Dy by dx. And dy by dx is what? Go back. Dy by dx, what you can call? Slope of tangent drawn drawn in yx graph. That's all. No, if you draw a tangent at one point, it is zero. That zero is here only. What we are showing it. Please do try to learn the graphs. Plotting graphs is very essential because it will give a lot of information. Then this mathematics, no, the graph will give a lot of information. Let me take the next question. Okay, I have one more. 5x cubed minus 2x square minus 3x. Let me define. I'm searching, is there any maximas, minimas exist for this given function? Let's see this. No, I'll proceed in this way. Let me differentiate this. The first order derivative of this will be equal to 15x square, 3 into 5, 15, 15x square minus 4x minus 3. Agreed? Then I'll differentiate again this function. For differentiate this one will be 30x minus 4 because the derivative of 3 will be 3 is a constant will become 0. So 30x minus 4 is what I'll get dy or double derivative. Now what to do here? Is it less than 0 or greater than 0? How to check is it a maximum or minima exists because we don't have any specific x can be anything, no? So what I do is like I just substitute the dy by dx equal to 0. Here, this one quadratic equation dy by dx equal to 0. That's what I'm indicating here, like this. Dy by dx equal because we know at maximum minima what should be the slope of tangent drawn at maximum minima or at critical point should be 0. So the first order derivative for both maximum and minimum must be 0. So dy by dx equals 0. So let this quadratic, we'll get this 15x square minus 4x minus 3 equals 0. We'll solve this quadratic equation. I'll get two values. X1 equal to 3 by 5, x2 equal to minus 1 by 3. What does it mean? We got two values. Again, what to interpret? Let me substitute these values, x1 and x2 here. Then I'll check the derivative, the second order derivative. What conditions will arise? So what we do is the next part of the problem is put 3 in 2. I'll solve it. I'll get double derivative as greater than 0. Y double dash greater than 0. Or d square over dx square is greater than 0. So what does it mean? Minima exists. That's all, finish. The minima exists here. At x equal to 3 by x1 equal to 3 by 5, minima exists. Then what about, sir, what about this? This value, I'm going to put it here. Then solving for y double dash will end up with less than 0. What does it mean? Maxima exists at this particular point where at x2 equal to minus 1 by 3. Then what about the curve? Look at the curve what we are having. At x equal to x1 equal to 3 by 5. At x1 equal to 3 by 5. I think some correction is there with the curve. It should be like this. There is some So here is what the minima. So this is the maxima already indicated. This is the minima. So what is the value of this? Minima will be 3/5. I think I the curve is like this. Huh? I don't know. Maybe yeah. Okay. No. This is -1/3. I can't show complete this one. Just I'm putting. So what is the maximum value of this? Maximum value 1.414. 1.41. Minimum value of this minus 1.44. This will become like a local minima. This is a local maxima. So what is P1? I think I have to show complete this. Please make observation. I think, yeah, till here. See this one. So therefore, this point P1 will become local maxima. This will call local minima. Why that local maximum minima? Why I'm putting that? Say that it is maxima only for these values. So only from here, the maxima it is maxima from here for this part of the graph. This point P1 is max local, no, not for total curve, because there is some point on a curve which is having value greater than y max. So therefore, it is maxima for only this particular region. The point P1 is a maxima for only what region? This region from here. Similarly, it is called as local minima. Why local minima? Because there are some points on a curve. There are some points on a curve. You look at this value, it is less than 1.44. So therefore, it is minima for what? Minima again for these values, for this part of the curve. Not for whole curve, no. So therefore, this will become local minima. This minima is for only this part of the curve from here to up to till here. Because there is some this value will be less than this y minimum. So therefore, this cannot be minimum. So therefore, I'll call local minima. Getting this idea, local minima, local magma, will put it. So there's a method of some, if you get cubic equations, I think little bit you have to be careful. Then if you end up like this, so first order derivative, make it equal to 0, then solve it, you'll get the values of x, then check it. Is it a maximum or minimum? Then you have to look at the first order derivative. After substituting the value of x here, check the y double dash value greater than 0, minima, y double dash less than 0, maxima. No, I was just discussing that local maxima, minima. The idea of that is what I'll try to share it here. What is a local maxima, global maxima? So some words are there. Here, as far as physics concerned, just basic idea, not this one, because you are going to go again in depth in the mathematics. Let's focus on this one. Okay, now you see this. There's a curve. There's a curve. Is it P1 maxima? P1 is maxima for this region only. Fine. Fine. Yeah, from year to year, it's a maxima. What about P2? P2 we can call it say global maxima, because there's no point on a curve which will have value greater than P2. So this will become global maxima. This can also be local for this region. Able to understand? But P2 is what? Is it a maxima for total curve? Yes. It is maxima only for this region? Yes. What about P1? P1 is not maximum for the total curve, only for this region. I'm putting it. Till where? Till the lowest point on a curve here. From it will start from here. So this will become a local for this point P1. So therefore, this will become local maxima, whereas this will be local maxima as well as global maxima. Better we'll call global maxima. Look at this again, the response of a curve. P4, this P4, there's a minima, no? But it'll be minima for this part of the curve. From here to till maximum highest value of this. This would be the lowest value for this region of curve. So this will become local max, not for total curve. For total curve, this is the lowest value. So this will become global minima. Or for this region, this will become again local. So P3 in general will call this a global minima. P4 is a local minima. This will become local for this region. Better say like this is a global minima, this is a local minima. Local for this region. I think some idea you got it. Let's take one more example. Minus 3x square. I'll solve this, the derivative of this. The first order derivative is minus 6 minus 12. I'll differentiate again. I get minus 6. So what is y double dash? It is less than 0. So therefore maxima should exist here. Where that maxima should exist, first order derivative should be equated to 0. I'll equate minus 6x minus 12 equals 0. X equal to minus 2. So somewhere here it will be maximum. How to calculate maximum value? This value of x you have to substitute here in this equation. Then put x equal to minus 2, minus 3 into minus 2 whole square, minus 2x is minus 2 whole square plus 5. What is the maximum value of y? 17. I think this is a better thing. No, put x equal to 0, you'll get 5. This value is 5. So like this, some rough idea. Oh, the curve will be like this. Here for x equal to minus 2, it is maximum. Will you prefer this method or this differentiation, sir, I didn't like it? Or will you go for the tabular column, what I shown, like x equal to 0, 1, 2, 3, 4, x equal to minus 1, minus 2, minus 3. Again, it will be very lengthy. It may take 1 day for you. Some of the problems, it may take 1 day to find out maximum. This is better, no? Better to learn that derivatives. So it will be very easy to identify the maximum minima. I brought one more. Just I'm sharing different numericals so that you'll get a confidence. Already you know concept, everything. Let's get into the problem. Y equal to minus x cube plus 3x plus 2. I think you are able to see very cleanly everything. This one. Let me differentiate first. Minus 3x squared plus 3x. Derivative of 2 is 0. Then I'll differentiate again. Minus 6x plus 0. So no, can what to do now? We can't conclude. It depends upon the value of x. So for that, what has to be done? This equation has to be equated to 0. Let y dash equal to 0 or dy by dx equal to 0. Solving this, I'll get the values of x plus or minus 1. For x equal to 1, let me check it. Where I should put this x equal to 1? Here in this equation. For x equal to 1, y double dash should be minus 6, which is less than 0. So therefore, a maxima exists for this. Then, at x equal to minus 1, at x equal to minus 1, y double dash equal to plus 6. So y double dash is greater than 0. So minima exists at x equal to minus 1. So if I go for plotting of curve, it is somewhere rough off like this. Put x equals 0, I'll get the 2. The value is 2. Then at x equal to 1 plus 1, it is having maxima. At x equal to minus 1, it is having minima. So that the curve will be roughly of this shape. Put y equal to 0, then you get the coordinates. It's a polynomial which we have to solve. The cube of that will predict where it will intersect the x-axis. Okay, fine. So now this P1, P2, what shall I call? This will be minima for what? This will be minima for till here. It will become local, no? Only for this part of the curve, it is what? Minima. Then what about this P2? P2 is maxima for what? Only for this part of the curve. I think I'll just show it. It will be maxima for only this part of the curve. Like this one, you can carry on further down. So only for this part of, what about here? For this part of curve, this cannot be maxima, no? So therefore, for this region only, for this part of curve only, this is maxima. So I'll call this as local maxima.